Then we're given a function f of x equals 2x squared minus 5x plus 12 over 3x. We want to find f prime of x. Now if you've kind of worked ahead or you're looking back now and you already know the quotient rule, you realize you can do this using the quotient rule. But you really don't want to do it that way. We always have that little choice between an algebraic step, a lot of times, and a calculus step, and very often the algebraic step is a better first step. And that's certainly the case here. So what we can first do is start by taking that single denominator and distributing it into each individual numerator. And in simplifying, we get that f of x is 2x over 3 minus 5/3 plus 4 over x. And now we can start to take the derivative. It's now into a really good format to do the derivative. Remember our rules for derivative. It will distribute over a sum or a difference, and we can also factor constants outside of the derivative operator. So as we take derivative of all this stuff, it will distribute through to each individual piece, and as it does, the constants again will factor out. So we'll have 2/3 times the derivative with respect to x of x. Now we can factor out the 5/3 and say 5/3 times the derivative of 1, but it's not going to make a difference. Whether it's 5/3 or whether it's 5/3 or 1, it's still a constant. And in the case of 4 over x, we're going to find it useful to write 1 over x as x to the minus 1 so that we can use our power rule. And so now as we simplify here, 2/3 times the derivative of x, well, derivative of x is 1, so that'll be 2/3. Derivative of 5/3, well, 5/3, as we mentioned, is a constant. So the derivative of all that stuff is 0, so that stuff I'm not even going to bother with. And then I just have the derivative of x to the minus first power. Well, by the power rule, that would be times the minus 1. So this is going to be minus 4, and then x to the negative second. And then by far the easiest way to simplify something you really want to get used to in calculus is the idea of factoring out a common factor, at least in terms of the variable here. In this case, we can factor out an x to the negative second. Doing so would leave us with 2/3. You know what, and while I'm at it, since I do have a fraction here, I'm going to also factor out a 1/3. Factoring out fractions is also a common thing. And so that would give me a 2x squared, right, because I'm taking an x to the negative second out, so I'm dividing that out. And so it would be in the bottom, so I'd have 2 over x to the negative second, which would be 2x squared. And in the second case, I'm taking the 1/3 out. With the first term, it's easy, it's a 2. In the second case, I'm taking a 1/3 out, but I'm dividing it. So that's really going to be 4 divided by 1/3. 4 divided by 1/3 would be minus 12. And then finally, putting it all together, we'll have 2x squared minus 12 over 3x squared. And that is our answer.